Hello children, let's continue with the concept that we started in the previous video. So we were discussing about direction of induced EMF, and we discussed that the direction of induced EMF, it depends on whether there is increase or decrease in the magnetic flux, and it can be obtained by two rules. We discussed about Fleming's right-hand rule in our previous video, and in this video we will be discussing about Lenz law, AC generator, and frequency of AC in household circuit. We will also be discussing about AC and DC, advantages and disadvantages, similarities between AC and DC motor and AC generator. Okay, so let's continue with Lenz law. So as we discussed that it tells you the direction of induced EMF. According to Lenz law, the direction of induced EMF is such that it opposes the cause which produces it. For this, we can refer to the diagram that we discussed in our previous video. So in the previous video, I have quoted here second and fourth diagram. I have redrawn the diagrams so you can see. In this, the magnet was moving towards the solenoid, right? So as it started approaching with velocity v, there was deflection in the galvanometer towards right hand side. So according to clock rule, the current is flowing in anti-clockwise direction, right? And according to the clock rule, this end will have polarity north and this is going to have south polarity, right? So what was there according to Lenz law? When north pole of the magnet is brought towards the end of solenoid in the direction B to A, right? In the direction B to A, right? The current is anti-clockwise. So the end A of solenoid becomes north pole to repel the magnet. Thus, it opposes the motion of the north pole. Why? Because of the same polarity. Because of the same polarity, it's going to repel, right? Thus, it opposes the motion of the north pole of the magnet towards the solenoid, which is the cause of producing it. So it was actually the change in the magnetic flux that was inducing EMF, right, when it was approaching it. But when it was approaching it, because of the current induced in the right hand direction and because of the clock rule anti-clockwise, this develops north pole, right? Because of same polarity, opposing it, right? Because opposing, it will start drifting, right? And the moment it will start drifting, away with velocity v, right? The galvanometer gives you direction in this left hand side. So according to this, okay, I should mark it here also. Now according to this, the current should be flowing in clockwise direction, that is from B to A. So the moment it starts from B to A, there is going to be change in polarity according to clock rule. So this will become south pole and this will become north pole, right? And now because they have developed opposite polarities, south pole will start attracting magnet of north pole towards itself, right? Yes, so when north pole of the magnet recedes from this end A of the solenoid, the direction of induced current in solenoid is from B to A, that is clockwise, and it becomes the south pole so as to oppose the motion of north pole of the magnet away from the solenoid, which is the cause of producing it. What was the cause producing? The magnetic field line changes, or I can say the magnetic flux, right? So the moment it recedes, it starts attracting. The moment it will start attracting, again we will have this situation. The moment it will start moving towards it, it will start repelling, and again we will have this situation. So this cycle goes on, right? This cycle goes on. So the Lenz law is actually based on the law of conservation of energy. The mechanical energy spent in doing work against the opposing force experienced by this magnet, right? And it is transformed into electrical energy. How come electrical energy? Because of induced EMF, induced current is there, right? So the electrical energy due to which the current flows in the solenoid, right? So here the mechanical energy because kinetic energy, because it is into motion, and change in position, that's why potential energy, right? So the mechanical energy of this is converting into induced EMF and induced current in the solenoid. So this is working according to the law of conservation of energy. So here we finishes with your Lenz law. So now let's work on the application of your this concept, that is electromagnetic induction, and the concept we are going to talk is AC generator. So let's talk about it. Now this is the diagram of AC generator, right? So first of all, we need to understand what is AC generator. AC generator is a device which converts the mechanical energy into the electrical energy using the principle of electromagnetic induction. And what is the principle of magnetic induction? That in a generator, a coil is rotated in a magnetic field, and due to rotation, the magnetic flux linked with the coil, it changes, and therefore an induced EMF between the ends of the coil. Thus, a generator, it acts as a source of current in an external circuit. This is the external circuit, and circuit containing load when it is joined between the ends of the coil, right? Between the ends of the coil. So here is a load, it will start working. So whatever thing you want to get it done, you have a load here and the thing will be done. Okay. So what are the main parts of AC generator? So children, let me remind you again that you have only and only construction and main parts of the AC generator, as I told you for DC motor as well, right? So these are the main parts of AC generator. Working is not there in syllabus. Only this diagram and the construction part is there in the syllabus. So what are the main parts of AC generator? We have horseshoe magnet, an armature coil is there, right? The slip rings, I have labeled here S1 and S2. If you can see here in the black, slip rings are there. Here we have brushes B1 and B2, and the load is attached. Whatever work we want to get it done, that gadget is being attached here, right? So as you remember, in DC motor, we had split rings. Split, two parts were there of the same ring. So that's why split ring. But here we have slip rings. Why? Because they can slip, they can move, right? So two rings are there and they can slip. That's why they have been labeled as slip rings. So like in the previous case also, DC motor, we had two brushes B1 and B2. Same again, performing the same function of conduction, right? They are completing the circuit. They are helping the ring to be in contact with the rest of the circuit, right? So this axle is being attached with the armature coil. So manually we move this axle, with the result this will come into motion. As soon as the armature coil will come into motion, there will be change in the magnetic flux. Why? Because the magnets are fixed, but the armature coil is moving, with the result the number of magnetic field lines passing per unit this magnetic coil is going to vary. So according to the principle of electromagnetic induction, as soon as the magnetic field lines associated with these magnets and the armature coil is going to vary, there is going to be induced EMF, which will produce induced current in the circuit, right? So this is in short, I have told you regarding AC generator. As I told you, description is not there. Fine. So now we can discuss about the differences in AC generator and DC motor, right? So first of all, we can talk about the basic purpose that for which the two things are working. Like for motor is basically to convert electrical energy into mechanical energy, right? Whereas in AC generator, mechanical energy, we apply force here, we physically we make it move, axial, and then rest of the things, they start working, right? So here mechanical energy is getting converted to electrical energy. This generator, it is working on the principle of electromagnetic induction. And I hope you remember electromagnetic induction, that whenever there is going to be change in the magnetic field lines passing through the coil, there is going to be generation of induced EMF, which will lead to the production of induced current, right? And what about DC motor? It works on the principle of, you remember Lorentz force, right? So it works on the principle of force acting on a current carrying conductor placed in a magnetic field, right? So when they were mutually placed perpendicular to each other, there existed a force in the setup which actually lead to the motion of the conductor, right? And the third point of difference is, in generator, the coil is rotated in a magnetic field so as to produce the electric current, right? Here we are moving it physically and it is moving in the magnetic field, right? And so as to produce current in it. But in DC motor, the current from a DC source flows in the coil. So input is the current. Here output was the current, right? There the current from a DC source flows in the coil placed in the magnetic field, due to which the coil rotates, right? And the last one, a generator makes use of two separate coaxial slip rings, as I told you in the beginning also. Whereas in DC motor, we had split rings, half ring of the same, you can say half part of the same ring, right? Which acts as a commutator. So these are the four basic difference between AC generator and DC motor. So can we talk about the similarity between AC generator and DC motor? Yes. So if you remember the diagram that we had in the previous video, both AC generator and DC motor, they are rotating in a magnetic field between the pole pieces of a powerful electromagnet. So if you see here, I have labeled north and south. Excuse me. So two strong electromagnets are there, right? Both in AC generator and DC motor, there is transformation of energy. So if you remember, in DC motor, what was the transformation? That was electrical energy to mechanical energy. We were getting our task done, right? As I quoted, all the electric gadgets at your place, they have electric motor, and depending upon our requirement, we attach the accessory to the axle, right? Whereas in AC generator, what is the transformation? In AC generator, we are converting this mechanical energy into electrical energy. So we are actually, the output is the current that we get from that, right? So now let's talk about, as we have already started, AC, we are discussing about AC and DC. So let's talk about distinction between AC and DC. Okay, so let me draw a distinction table, or a differentiation table. So this is a table differentiating DC and AC. The very first thing that we should know, what is DC and AC? DC means direct current and AC means alternating current, right? So direct current and alternating current, that is what we are going to differentiate. In direct current, current is of constant magnitude, right? So same amount of current flows in DC, whereas in AC, varying periodically with time. So if you check out, the next point is related to it, right? Of constant magnitude, in the same direction, constant magnitude, but it is varying periodically. Wave is there, plus 50, minus 50, plus 50, minus 50. So 50 hertz, plus minus 50 hertz. This is also known as sinusoidal wave, okay? And the source of DC, it is obtained from a cell or from a battery, right? Whereas AC, that is alternating current, is obtained from AC generator. Right now we discussed that We convert mechanical energy into electrical energy in case of AC generator, right? So AC generator and mains. Mains means the power generation is there, and whatever we are getting in our household, right? That is termed as mains. So the source of AC is AC generator and mains. So let's discuss about advantages of AC over DC. AC is cheaper and easy to generate than DC. This is going to get exhausted after some time, right? So we need to throw the cell, or we need to have a chargeable cells, maybe costing high, right? Whereas AC, it is easy to generate and power loss is less. I'm talking here about household circuits. The consumption at our household is AC. Fine. Why not DC? Because by the time it is generated there, and by the time it reaches to our place, it will get exhausted in the way, right? So whatever is produced or we buy and whatever we are actually getting, it's going to be of large difference. Fine. Next is the efficiency of his AC generator is higher than that of DC generator, and it's very easy to change AC into DCs, right? We have stabilizers, we have various devices that converts AC into DC. Next is the magnitude of AC voltage can be increased or decreased by the use of step up or step down transformer. But children, we don't have transformer this year in our syllabus, right? They have deleted this topic this year. But otherwise, just for information, transformer, what is a transformer? Transformer is a device by which the magnitude of alternating EF can be increased or decreased. Like we had in AC, there was induced EMF, isn't it? So that alternating EMF can be increased or decreased. Okay, I'll not be going into detail. Fine. But otherwise we have step up or step down. We can step up means increase, step up down means decrease the induced alternating EMF, right? And next is AC can be transmitted over a long distance without much loss in energy in the line wires, as I discussed earlier also, that losses are going to be very high in case of DC, but it is not that much in AC. So whatever transmission is there and whatever we are getting at our place is going to be, there is going to be less difference in case of AC, but a huge difference, a huge power loss is going to be there in DC. So what about frequency of AC in household supplies? As I told you that here we have plus 100 and minus 100, right? So we have plus and minus 50 Hertz. Why plus and minus? Because change in polarity. This is plus and this is minus, right? So in our houses, we have electric supply of frequency 50 Hertz. The polarity at the N terminal changes 100 times a second. 100 times a second, okay? So you can well imagine how efficiently the system is working. So the next that we are going to talk is about frequency of alternating current. The alternating current has the frequency equal to the frequency of rotation of coil. Which coil I'm talking about? I'm talking about the coil of AC generator, right? So if the coil makes n rotations per second, the magnitude of induced EMF at any instant will be given by E is equal to E naught sine 2 pi nt, right? This is the frequency. And what about the current? The current is expressed as I naught sine 2 pi nt. And what does I naught and E naught suggest you? E naught and I naught represents the maximum value of EMF and current respectively, okay? You need not to go in details, only these two expressions you should be aware. They may ask you about these expressions, that's all, okay? So the maximum value of EMF induced can be increased. How can you increase it? By increasing the number of turns in coil, by increasing the area of cross section of the coil, and by increasing the speed of the coil, okay? So bache, with this we finishes with the chapter electromagnetic induction, and We'll be starting with the new concept in our new video, and I hope so that you're watching these videos carefully and you are absorbing maximum from these videos, right? And my suggestion, just be regular. Daily you need to study. I'm not telling you to complete every chapter every day. I mean, you're working on 5 to 6 pages daily. No, I think in a video we are just covering maximum 2 pages, or it might be 2.5, right? So I don't think so this is a very hectic job for you people, right? So work regularly, be sincere, right? Give your best. And with this note, I'm just going to say goodbye and take care.